So today we're talking about gluconeogenesis. And gluconeogenesis is simple. It's just taking non-carb, so non-glucose substrates and turning them into glucose, right? And the two most common ways of doing that in the human body, or the two main ways, are going to be through amino acids and triglycerides, okay? And so amino acids are the most commonly used form, okay? And so what happens is the body is running out of blood glucose and it's running out of stores in the liver. So it needs to look to other sources. And it derives first from protein. All right. So what it does with amino acids is called oxidative deamination. Okay. And what that does is it separates the amine group from the carbon skeleton, also known as keto acid. All right. And all 20 amino acids have a different carbon skeleton. All right. But the two of the most common ones are going to be the glucosogenic amino acids and the ketogenic amino acids. Okay. But right now we're only concerned about the glucosogenic amino acids at the moment. Okay. So those are being turned into glucose by being turned in pyruvate, which will then be turned into acetyl-CoA, which can be then taken into the mitochondria in order to enter the Krebs cycle. And then we get glucose as a production of the Krebs cycle along with ATP. All right. And then outside of protein breakdown, okay, you also have what's called the glycerol backbone from the triglycerides. Okay. So when you break apart the triglycerides from the adipose tissue or whatever, okay, you break apart the glycerol from the free fatty acids, okay, in which the free fatty acids can be used in the mitochondria as energy on their own when they're carried across the wall by carnitine. But then we use the glycerol, we take it into the liver, which it is converted into acetyl-CoA, right? And then it can be enter the mitochondria and continue the Krebs cycle, okay? And then again, at the end of the Krebs cycle, we get glucose, all right? So it's simple stuff. Your body just takes whatever it can and then breaks it down and then converts it into either pyruvate or acetyl-CoA. And I believe it says somewhere in the book, if you can get pyruvate, you can get glucose. And that's gluconeogenesis.